This is a 4-register RAM design that I made over the course of 2 days, and so I'll basically just be explaining some of its functionality and the general design process that I made of it. So as you can see, there are 5 rows of redstone lanterns. So we have register 1, register 2, register 3, and register 4. The RAM registers were inspired by Batwings, except the only difference between this one and one made by Batwings is that we have a setter. Where's the setter? Yeah, right here. Setter. No, wait. To start. Setter. Which basically just takes the function of locking the RAM, so nothing else can access it. Kind of like a protection kind of thing. And then over here, these 8 lines surrounding the RAM itself are the bus in which data gets sent through. Now going up here, we have our input where we can send data to the bus. So if I were to, it would get sent to the bus. For the record, before it gets inputted to the registers, it's going to mirror itself as it makes this turn. So this bit will get sent to the leftmost despite being on the right. Now we go to our control center, which is just right below the input. We have our individual registers, register 1, 2, 3, and 4, but we have 3 functions. We have the enable function, we have the clear function, and we have the set function. The enable function will just display whichever register you enable and send it to the bus. So if I were to enable, if I were to select register 1 and enable it, that data will get sent to the bus. And if I were to disable it, then it just stops. Now, if I wanted to send information to the bus or to one register, let's say register 1, first I would select it, and since there's already data written on it, I'm going to clear it, and that would all get set to 0. Now that I've selected register 1, I'll write down some data. It gets sent through the bus, and then I'm going to use the set function. So once I enable that, that data will get written on, just like what we wrote. And now I'm unlocking it basically. And so it doesn't matter now what I set the bus to. If I set it to all zeros, that will remain the same. So now, if I wanted to send, let's say, the information on register 1 to register 2, since there's already data written on register 2, what I'm going to do first is I'm going to clear it. And then, what I'm going to do is I'm going to enable register 1. And then I'm going to set register 2. I don't know why it's... Is it not... Oh. I'm stupid. There. Hello? Okay, there. Minor error. But it doesn't matter. I just placed it on the repeater. So now I basically clone the data. So let me just disable. This very weird control mechanism will be edited. What I do plan on having is having an encoder so that so that we can have a processing unit that will just accept 2 bytes of information for data. So you can individually set RAM registers, but also do some mathematical operations. For now, this is just a memory module that I've been working on. So hopefully this bus will get attached to other processors, and this will also get attached to a processor. I hope that you've enjoyed this general design, and if you have any comments, suggestions, ideas, then please feel free to tell me. Yeah, thank you. Otherwise.